And you might notice that it just so happens that I can simplify this. Not upstairs. Oh, and I forgot the 0 there. But I can simplify this downstairs. Because I can drop those parentheses and I end up with x plus delta x minus x. And you can see that our x's will end up going away. They cancel out. So ultimately, I can say that the slope of my tangent line is equal to the limit of delta x as it approaches 0 of f of x plus delta x minus f of x all over delta x, which you had a homework problem that looked almost exactly like that a couple weeks ago. And you definitely had many that looked like this, but where they plugged in a very specific function for your f of x and f of x plus delta x. And I warned at least some of you at that time that that was very specifically on purpose so that we could do a problem in the future, and now it is the time for that problem in the future. And remember also that this whole idea of finding the slope of the tangent line is one of the 2 problems that led to the invention of calculus. This isn't just another problem that we're working out. This was a defining problem, that if it was not for this problem, we would not be in a calculus class today. The subject just wouldn't exist. Any questions so far? Okay. So let's do some example problems. And in other words, we're just going to practice limits like we did before. And that's really what we're going to be doing throughout today. So let's find the slope of a function Emily, I just saw your note, and I've had the exact same problem. Many times. Many, many, many times. Okay, so for this, we need to understand what y2, y1, x2, and x1 all equal. Remember, your y2s are your f of x plus delta x's. And the y1s are your f of x's. x2 is x plus delta x. x1 is just x. So I can plug this in to find out what it would be for this function. And conveniently, there's not too much you have to do because like your x's are already simplified. And your y1, technically, you just copy that down. But your y2, of course, takes just a little bit more work. I personally like to put some sort of bracket system or parentheses around my y2 versus my y1 because we are subtracting here. You do want to remember to distribute that negative. I find you don't necessarily, it won't make a difference for the first thing, the y2, if you forget to put brackets around that, but you're really likely to make mistakes on the subtraction portion if you forget to put the negative or the brackets there, just to remind you that you must distribute. Oh, and let's fit our limit. I almost forgot the limit. So this one I'm going to work out with you for you. But don't worry, we have plenty of examples that I'll let you take off on your own with. So I'm going to distribute. I'm going to distribute this negative. And I'm going to look for opportunities to simplify. I'm going to pause a little bit because I know you guys, I'm getting ahead of you. But I want you to look at that function and figure out what can you simplify, what can you get rid of. We aren't even really using any of our tricks yet that we taught you for limits. It's just going to be arithmetic. At least at this point. Upstairs, what do you see simplifying? What can I get rid of?
You can get rid of the 2x's.
Mm-hmm.
Or the 2x.
Because I've got a positive one and I've got a negative one. They cancel. We can't get rid of the delta x yet, but you're actually going to see we will be able to soon.
You can also get rid of the 3s, right?
Uh-huh. Yep, because we've got a negative 3 here and a positive 3 here. They cancel. So let's write what we have left. All I'm left with upstairs is the 2 delta x. And on bottom of delta x, looks like something will cancel there too. You've got a circus going on behind you? I think that was Andrew who unmuted, but I'm not sure. Yep, it is. Yep, go for it. Sometimes Zoom hides our secrets, sometimes it reveals them. I can hear the music, I cannot hear you at all. Yeah. Well, hey, it's helpful because all of us this morning were saying that how tired we were and how sleepy we were, but I think you're waking us up. All right, what else cancels? All right, Andrew typed it in the chat. We got it. Your delta x, you got one upstairs, you got one downstairs. Those go away. Now we have the limit as delta x approaches 0 of 2. What is the limit of that function?
2.
It's 2. So this means that the slope of our tangent line is equal to 2. Now let's go back and talk about, does that make sense? Forgot T there. Does it make sense? Let's do it in another color. Does it make sense for this function to have a slope of 2 at our point? Yes or no?
Yes.
Why?
Because, I mean, if you plug in 2, it equals the same point as y.
Well, when you say plug in 2, you usually mean plug it into x. But what do you mean? Think about what this equation is. What kind of line is this?
That's it's a linear.
Linear. Just looking at the equation, what's the slope of that line?
2.
So, it doesn't even matter what point we tried to plug in. We couldn't even plug in an x. Turns out that has a slope of 2. And we just proved, using limits, that it also has a slope of 2, which we would have known back from algebra days. Obviously, that's kind of the easier problem, because the problem we really have is finding the slope on curves, not straight lines. So let's do one with a curve now. But, just to show you this does work, we get the slope that we expect in our y equals mx plus b. Alright, put your hand on your head if I can scroll down. And Brooklyn, EJ, and Emily, you'll have to give me feedback another way. Okay, everybody who I can see your faces is giving me feedback. I'm going to go ahead and scroll. Okay. EJ, thanks for letting me know your hand's on your head. Emily, I didn't hear from you, but I'm going. Alright, so let's do this with an actual curve now. Find the slope of f of x equals x squared plus 1. Got a quadratic, got a parabola, definitely have a curve in this case, which means the slope of our tangent line is going to be different at every single point. So let's find it at this point and at this point. So in other words, this is two different problems. Problem A, problem B. This is not just one problem, but I'm going to solve it generically first, so I don't have to do the work twice. And I'm just going to go straight to the slope of our tangent line is this equation. I'm going to give you a head start this time. I want you to go ahead and set it up. I want you to plug in what f of x plus delta x looks like. I want you to plug in the minus f of x. And then I want you to start working on the limit and start simplifying where you can. I'm only going to give you like a minute head start. So if you get stuck, then just refer back to my screen. But let's see what you can do on your own before I get going. Check yourself against my work. Don't forget that since we're squaring a binomial, you got to think about things like the box method to be able to do that. And then look for opportunities to find things that cancel. Can you tell me what will cancel?
X squared and negative x squared.
X squared and negative x squared.
Both the ones.
And our ones here. And do you want me to give you a helpful hint for things that'll cancel?
Wait.
Keep
When
making-
it's divided, divided from both?
What was that?
Like, so it would just be at. When we divide it, wouldn't we get rid of the delta x in both the.
Our next step we can. We can't until we divide out, or we cancel out the x squared and the 1. And the 1s, I should say. But once we have things that just have delta x left, then you'll be able to divide that out. I do want to talk about these things that canceled in red first, though. Here's a hint that you're going to see. Your f of x will always cancel out. So you should see all of the terms that were in f of x cancel. Early hint for you for what's coming. So I should see that an x squared will cancel and a 1 will cancel. Whatever's in that location, that will always cancel. Alright, and what Keaton said now is I do have a delta x in every term. That's going to be the same thing. Oh, I forgot the 0 over here again. As 2x delta x over delta x plus delta x squared over delta x. So you can see that you're going to have something cancel from each of them. And I had a reason for changing colors, but then I didn't actually go through with what I was thinking. So sorry, that one's in a different color. Now, what is the limit as delta x approaches 0 of 2x plus delta x? Plug in delta x equals 0, and what are you left with? Not 0. Not entirely, because there's still something else left in the equation.
2x?
2x. Because when I plug in delta x equals 0, just this piece goes away. I couldn't do it here because it was going to give me, something that was undefined. But once I no longer have delta x on the bottom of a fraction, it's legal just to plug it in. I get an equation out of this. And then remember, I want to find the slope at these 2 points when x is negative 1 and when x is 0. At, what was that whole point? Negative 1, comma 2. And for b, was that 0, I think, comma 1? The slope of your tangent line would equal 2 times the x value, or the slope of your tangent line would equal 2 times your x value. And for each of those, you can simplify. And I can double check that. Let me get myself a new graph here. It'll cover it up there for a second, but our original problem was x squared plus 1. Oh, that's the problem. Okay. Plus 1. Plus 1. There we go. And let's find where I put my annotate. So, at x equals -1 right here, what we're being told is this slope is equal to -2, or down 2 over 1, down 2 over 1. And we're being told, let me get it in different color. We're being told that this point right here has a slope of 0. Do both answers seem reasonable to you? That if you were to just look at the equation and draw in a good guesstimate, that it would be something close to that? Got a couple thumbs up, but mostly just kind of like deer in the headlights look. Which calculus will do that to you sometimes. And don't worry, I'm not expecting you to be pros at it the first time or two we do this. I also can guarantee that I am probably going to take the entire class period, or close to today, not just synchronous time. But if you do have to leave, just send me something in the chat once synchronous time ends. Alright, so where all this is going. At the first day of school, I told you that there were only 3 topics in calculus. Do you remember what those 3 topics were? 3 topics we would learn this year. Go back and look at your notes from the first day.
Was it? It was derivatives, integrals, and is it limits or?
Uh-huh.
Oh, wait,
Limits,
really?
derivatives, and integrals. We've taught you limits now. We're done teaching you limits. What we're doing today, like I said, is we're starting derivatives. And we're going to spend from the next 2 to 3 months, probably about 2.5 months, studying just derivatives. And what you can do with them, and how can you take them when they're in different forms. We're going to be pretty creative. But let's teach you how we go from limits to derivatives now, because secretly, that is what we have already been doing. I'm going to clear what's on the board. Minimize this. And let's scroll this so I got some extra space. So, the definition of a derivative. And this comes from page 99 on your textbook. Okay, I reworded it just a little bit. It is true that not every equation will have a limit that exists. Just mathematically, we can't always find it. But we're going to focus on the ones where we can, which will be still plenty. And ultimately, what we see here is your derivative equals the slope of the tangent line. Now, if I want to tell you that we're going to do a mathematical operation on a function, and let's say that mathematical operation is to add. I have one symbol for add, and just one. Let's say I tell you I want to subtract. I have one symbol for subtract. Let's say I want to multiply. Technically, I have three for multiply, because I could do the dot, I could do the x, or I could do just two things next to each other. Or even four, because I could do parentheses. So in multiplication, we start to see there's multiple ways to write out that operation. With division, I could do the divide symbol, or I could just do the fraction bar. Again, more than one way to write it out. Here, though, we've got 1, 2, 3, 4, 5 different ways we can write out the derivative. If you see any of these, it means we're taking the derivative. And let me tell you, we actually will use most of these in this class this year. The only one that I will not use is this one at the end. You're more likely to see that in differential equations than in a calculus class. Differential equations is basically like calculus 4. So it's something that will get you used to the notation, but do go ahead and make a note that all of them are legal ways. Your textbook will use all of them. I will use all of them. The AP test will use all of them. We'll get you used to them. But be aware, it's got multiple ways to say that we're going to take the derivative operation. Just like when we multiply, we've got different ways we might write that out. And it's just personal preference, usually, for that problem that's in front of you. Do you have any questions so far? Okay. Now we're going to hurt your brain a little bit on this one, but not because of the calculus, the limits. We're going to hurt your brain a little bit because we're going to get a little more expansive in the algebra. You ready for it? Keaton says, no, all of you say no. Keaton emphatically says no. Alright, well, let's do it anyway. Alright. Let us find the derivative of this function. And so for the derivative, my derivative is, remember that equation I just gave you. It's going to be my f of x plus delta x minus my f of x all over delta x. Now the reason this one's going to hurt your brain a little bit more is we're cubing it, a binomial, instead of just squaring a binomial. You got two ways you can do it. You can do the box problem twice, where you take x plus delta x times x plus delta x, find what that equals, then take that answer in a new box problem, times delta x again. You also, if you're familiar with Pascal's triangle, that's the shortcut. How many of you have learned Pascal's triangle? One of you? Okay. Let's do the box method, so I'm not teaching you too many new things right now. But if you know Pascal's triangle, go ahead and use it. It's a super fast shortcut. I'm going to give you a couple minutes head start on this problem before I take off and start it myself. And this one does have enough pieces. Be super careful to write everything out every time. It's going to be easy to miss something, and it throws off your whole answer. All right, Andrew, or sorry, not Andrew. Mia, you got it. Andrew's name is down below in the chat because he was the last one of the last ones to send me something.
This one back?
Uh-huh.
Since I know Pascal's triangle, I'm just wondering, like, do you have to memorize that? Like,
Pascal's triangle?
yeah.
No, there's a pattern to it.
Yeah, I know the pattern. It's just like I'm wondering, it's like, do you ever have to like memorize it? So, like a few rows.
I'd always, for me personally, whenever I have to use Pascal's triangle, I always start at the beginning and use the pattern. And then work my way out to put as many rows as I have to put in. Usually, like, I personally have never had to go past 5 or 6 rows. And even then, it's rare for me to have to go past 4. Like, and I'm saying this knowing full well I've had way more math classes than most of you will ever have. And that's as far as I've ever had to go.
I remember when I first learned it, I had to go to 12 rows.
Yeah, when you first learn it, we make you write it all out, certainly. But realistically, I can tell you I've never had to then in a problem outside of just in the process of learning Pascal's triangle. When I've used it, I've never had to go past that. And for those of you that don't know what I mean, I'll show you quickly Pascal's triangle. And it's just a shortcut. Kind of like Polydoku's the shortcut to long division of polynomials. Just a shortcut that gets you through all of this stuff a little faster. Now, if you're as far as I am, on the left, I want you to look for those opportunities to find what will cancel. Nelina.
X cubed into it.
And like my hint was before, whatever's in your f of x location, everything there should cancel. Yeah. So my x cubed.
and also x cubed. Wait, yeah. X cubed, 2x, and then... Yeah, wait. And then you'd subtract the... not subtract. I'm just kind of blind. Then add the rest.
We would then divide out our delta x, but I am going to go ahead and rewrite it. And I'm going to go ahead and rewrite it the way I did before, where I'm going to give everything its own denominator. Just so that you can, hopefully not make any mistakes in how many delta x's you cancel out in each term. And I know I might be going just a little bit faster than some of you are. I just want to give you something that you can go off of if you're getting stuck. Because problems like this, like I said, it's not the calculus part of it that's the difficult part. It's the algebra. And you're going to find that a lot in this class. You're going to get to know algebra and trig better than you ever did in your algebra or trig classes. And then cancel out where you can between what's upstairs and what's downstairs. I do think this is probably the most complicated problem we're doing today too, just because it's the longest. And then once you get to the point where you can legally plug in delta x equals 0 without having any undefined items, do it. Have those pieces cancel, they go away. Keaton, your answer is close, but it's off a little bit.
Wait, is it just 2?
It's more than just 2, because it's not x that's 0, it's delta x. And I see a delta x here and here.
So, yeah, it's just 3x cubed plus 2.
Yep, these terms go away because of delta x equaling 0. And my final answer, after I take the limit, is just 3x cubed. Oh, hold on. Somewhere along the way, let's actually not. Let's put that in a different color. Notice here, I made a mistake here. I took this in, oh, I still am on the eraser. This was, I had a 2 squared up here, and I changed it to a 3. And then I carried that mistake through. That's easy to do on these problems. I apologize for making that mistake. My answer is going to be 3x squared plus 2. So my derivative is 3x squared plus 2. And I can use this equation to find the slope of any x value, or in other words, at any point. So like before, when I had you do the derivative, or I've had you find the slope at 2 different points. We found the equation first, and then we plugged the points in, instead of trying to do the process twice. What's great about this is you find the equation, then you can find the slope at an infinite number of points. That's what the derivative is. It's the equation that gives you the slope. Okay, for this question especially, do you have any questions? I do have 2 more examples that we're going to do together, just to practice different things with algebra. But let me briefly mention Pascal's triangle. And then I'm thinking I will do a video on Pascal's triangle for your homework. It might come in handy. Pascal's triangle you use when multiplying a binomial by itself. And a binomial is just anything that's like a plus b or a minus b. So in this case, our binomial was x plus delta x. And that's going to be the same binomial you're going to use over and over and over again today. Pascal's triangle is almost an artistic mathematical pyramid. What it is on the outside, you always have 1s, and anywhere you have an inside term, you're going to add those 2 together to find what goes in that spot. And our first row has 1 term. Our second row has 2 terms. Our third row has 3 terms, and I bet you can see the pattern. How many things do you think our fourth row will have? I just wrote it down.
4.
There we go. And so forth. Our fifth row will have 5 terms. And I always have 1s on the outside. And then I always use the 2 things that are above something to come up. I add them together to come up with what goes in that spot. So between the 2 and the 1 here, I'm going to have another 3 because I'm going to add together the 2 and the 1. Here I'm going to add together my 1 and 3 to get 4. I'm going to add together my 3 and my 3 to get 6. I'm going to add together my 3 and my 1 to get 4. And then again, I have 1s on the outside. Now, what's convenient about this, and I'm not expecting you to become a pro because I'm going through this pretty fast, but what's convenient about it is this would be your binomial to the 0th term. It would equal 1. Your binomial to the first term would equal just that. Your binomial to the second term would equal the first thing squared plus 2 times a times b plus the second thing squared. And then all of those you've seen before, except for you don't usually write the coefficient of 1 in front of things. Here is the problem we just did, and here is where this starts to get super handy, and it's going to be easier to teach you the trick here. You're going to take the first term to whatever power is here. And your other term, let's see, let me scroll. So I'm going to look at the 1, 3, 3, 1 row. I'm going to take the first term to the 3rd power and the last term to the 0th power. And then I'm going to subtract 1 from the a and add 1 to the b power every time. So I get a squared b to the first. I take 1 away from the a cubed to get a squared. I add 1 to the b to the 0th to get b to the first. I take 1 away from the a, I add 1 to the b. I take 1 away from the a, I add 1 to the b. And simplified, I get it will give me the same answer as I got here. Except for instead of A's, I'm using X's. Instead of B's, I'm using delta X's. Let's copy that. And let it catch up to me. There we go. All right, so I can see I have my first term cubed. My second term, I have the x part is squared, and then my b is the same thing as my delta x. And then my next term, I lose 1 power from the x, I add 1 to the delta x. I lose 1 from the x, I add 1 to the delta x, and my coefficient's now 1. So if you know Pascal's triangle, it just means anything where I start adding powers here can help you go through faster than doing the box problem over and over again. But don't feel like you have to use Pascal's triangle. I just want to introduce that shortcut, and I think I'll do a video just on that. I probably won't have time right after your class, but I'll do one after physics ends. Because that one is a super helpful tool to help you get through your homework faster. Any questions? Like I said, I do have 2 more problems. I know your brains are hurting. I know it. Doesn't mean I'm not going to hurt them a little bit more. But with what we have, at least I feel like, even though the algebra is a little different, I'm hoping we don't hurt them quite as much. 2 more problems, then we're done. And I want to make sure I go through them because I'm giving you homework that looks like this. I'm only spending 1 day on this section. Some sections I will spend 2 to 3 days on. Sometimes even a little longer if I need it. But this is not one of them. I want to get to that shortcut for you. Anyway. Started getting ahead of myself, but I want to find the derivative of this function. Just the square root function. Not everything will be your traditional binomial. Sometimes we're going to have to depend on those limit rules that I taught you in the last section. So, for example, when I set up this limit, remember it's going to be f of x plus delta x. So here's that. Minus f of x all over delta x. Going to use this equation in every problem today. All right, now I know we're sleepy and our brains hurt, but do you remember the method we used to solve a limit when it looked like this? Emily says yes. Andrew says, It started with an R. Do you remember the name of it? I'll give you the name while you're looking, but I want you to do something for me. I want everybody to stretch. I want everybody to stand up. I want everybody to like get out of your chairs. Get out of your chairs. Come on. Stretch as high as you can. Go like this. Go like this.
I think I have it.
What is it called? Well, everybody's
Rational
stretching.
fraction.
Rationalizing is what I'm looking for.
Oh wait, rationalizing. My bad.
Rationalize. All right. Rationalize. Everybody woken up a little bit? Keaton says yeah with a big yawn. All right. We're going to call it, it's called rationalizing. With rationalizing, that was the method where you're going to use what are called conjugates. So you look upstairs and you're going to take that binomial, but you're going to use the opposite sign of whatever's in the middle. And since we can only multiply by the number 1, we're going to turn it into a fraction, and whatever you do upstairs, you have to do downstairs too. These are called conjugates. And let's even make an extra note on that, conjugate pairs. Or when you had a plus b and a minus b. And remember that what's great is when you have a conjugate pair, they always multiply together to make this difference of squares. And what I like about using them when we have square root problems is the squared cancels with the square root. It goes away. So we still have this first term, but because it's a square root inside a squared, it will go away. And we still have the second term, but because it's a square root inside a squared, it will go away. Keaton, you're close. There will still be yeah, you're close. Oh, and then let's see, I forgot. That was me multiplying across on the top. On the bottom, I do still need to multiply across here. So I can't forget that. I almost did. Worst part about this is lots of pieces. I want you to look just at the numerator, just upstairs, and tell me what will cancel.
The x's.
On upstairs we've got x and minus x. Those go away. And I know you could do the next cancellation step without writing it out again, but I like to write it out again because when I try to show people too many cancellation steps in one thing, it just adds to the confusion. I prefer to show as many steps as I can. At this point, what will cancel?
Delta.
Delta x, because I've got one upstairs, one downstairs, and the one downstairs is factored out, which is important. At this point, can I legally plug in delta x equals 0 and be okay? In other words, don't get does not exist. Got some confirmations. This thing will go away because it equals 0, but only that piece. And since there are two of them, it is legal to put them together. And of course, at this point, I could use my square root rule to move it upstairs. I'm not going to. I'm going to say let's leave it there. And I'm going to add a note that this will be true. Your derivative equals 1 over 2 delta, or 2 square root of x for x's that are greater than 0. Why couldn't I have an x smaller than 0 for this answer?
Because you have a square root and it's negative, it doesn't exist.
If I plug a negative number into a square root, that's an imaginary number that doesn't exist. Imaginary numbers are like your imaginary friends. Not saying they don't serve a purpose, but if you can't touch them, if somebody else can't go up and go boop on their head, then it's not real. It's not going to work. Why couldn't it equal 0? What's wrong with x equaling 0?
Because then it would be undefined.
You'd have 0 on the bottom of a fraction and you get undefined. So that note that we put on isn't anything that's special about the derivative. It's just mathematically that's a fact. Okay. You ready for one more? You think you can handle it? Do you want me to make a video of it that you can watch later? Okay, because I have hurt your brains enough. And it's good because I actually discovered I actually have 2 more problems, but the second one was shorter. I will make a video out of this afternoon, and a Pascal's triangle. Let me make a note, actually, so I can remember to do both videos. And I'll put it on the lesson page. Because I do still want you to see the example, because you're going to still have homework on this. And if you can do Pascal's triangle, you don't have to, like I said, if you don't learn it, it's not going to hurt you at all. But for next time's lesson, I'm going to give you a bunch of binomial problems to solve. So in other words, I'm not going to worry about all of this stuff with square roots and other functions. I'm going to give you problems that look like this and like this and like this. So in other words, first, second, and third power functions. And I'm going to give you a bunch of them, and I'm going to see if you can find the shortcut without me telling it to you. So the faster you can go through, especially problems like this, just the faster you'll find the shortcut. And that's where Pascal's triangle would come into, would be handy, just to be able to do it faster. But you still can find it if you do it the way we taught you before. All right, let's take roll. Let's get you out of here. You can still start your homework. You can still do a lot of it without seeing these last examples. But I will get those videos up after I take, or after B3. I'll work on those during lunch. All right, so one more time through roll. If you have any questions, and today, of all days, I do expect there could be questions, stay on. For those of you that came in tardy, let's go through this one more time. Instead of a quiz, you have test corrections. And for the test corrections, what I want you to do is I want you to get a piece of paper. I want you to fold it in half. I want you to rework completely. I want to see every step on the left, and I want you to explain on the right. And you can explain the mistake, or explain the rework in words if you don't remember the mistake. And if you try to tell me in the explanation, I didn't know what I was doing, I got confused, any of those are cop-outs. I will not take it. I will take points away if you try to give me anything like that. I want you to be very careful. Like, your mistake can't be, I didn't know what I was doing. Okay? I want something specific, like, oh, I used a plus instead of a minus sign in this place, and it threw off my answer. That would be a mistake that you could identify. I tried to use this rule instead of this rule. But just saying I'm confused, like, that's not enough. I need more detail than that. And the reason I need more detail than that is you need more detail than that. As I said before with the rest of the class, if there's a question that I see everybody's missing, you can guarantee that question's going to show up on the next test. And the next one, and the next one, and the next one. Until I feel like we've got it. Okay? Alright, so at this point, let's take roll.